day to you. This is Anagalactic broadcasting to you from Chico, California, bringing you a geometry that has never been used, but it was always waiting to be used. This is the beginning of a new series to follow on the series of 2022, which ran to over 250 videos, which was, as I've explained, mostly in December to sum things up. What happened in the 6 months of broadcast from June to Christmas of 2022 was the follow-up to the previous 6 months of study. Basically, a year ago, right now, I began to notice that I was approaching perhaps a discovery. And I began making videos at that time, but never with the intent to upload them to YouTube. Those videos are still on my hard drive, but the 290 videos that I ended up uploading over a 6-month period were pared down to about 260 due to the necessary or predictable excesses of a total amateur in scientific presentation. And so just a little bit about myself so you know who I am in some way, this person who's going to tell you about a new geometry. I'm not really a scientist, although I was in the industry. I made my living as a database programmer, which in those days, which was 3 decades ago approximately, one in my position had to do many things. I was a programmer, but I really made my living as a database engineer. I wrote and managed databases for large companies and a few small ones. I was a freelancer, but I do not have any degrees. And perhaps one looking back could say that I might have gone into some scientific endeavor, but it would have had to have started early. That's just the way it is in this world. But by the age of 17, it was quite apparent that I did not have the mathematical ability which would qualify me for a modern scientist. One has to be an absolute wizard at mathematics to excel in science. Many of my broadcasts not only dealt with geometry, but the bracketing information for why this geometry would be useful. For after all, don't we already have a geometry that's just fine? That we do, although it's a relative statement to assert that it's just fine. It certainly has been just fine as far as we know, because it's the only geometry that we've ever used. Linear geometry, which raises the very first question: could there be another geometry? That's a very provocative question, because so far the answer has been no. So it's really, in some small or perhaps more than small way, a revolutionary suggestion. But then what would be some of the hurdles against such a notion? The first few are quite serious, and I would suggest that it's just for some of the basic reasons of how difficult it would be to come up with a new geometry when this would be other than linear, a non-linear geometry. I checked very carefully just to be sure, but I have been studying this a long time, and nobody has ever suggested that there might be some other geometry other than linear geometry. A footnote should be thrown in here, just for completeness. There are several kinds of linear geometry. And any scientist would know that, and anyone who remembers their lessons from high school or even before would realize that these are perfectly patently obvious statements. But what is linear geometry? That actually was only fully proved in my lifetime one of the men who was responsible for finally giving us a complete, consistent definition of linear geometry. That man was John Horton Conway. And some men's name you always give the middle name as well. It's just a convention that we humans enjoy. His for men's names in science, when I'm writing, I will just put J. Conway or A. Einstein, because I prefer not to think of the men. I'm not really interested in the men and women who discovered whatever they discovered. It's what they discovered that's important to science. But we are human, and certainly so am I, and I would be a complete hypocrite if I did not admit that I am vastly interested in these men and women. Not all of them, because that would take too much time. That really was the reason for my preference. And as far as my experience with the subject of geometry, it's really only, other than the regular education in high school, I did get up to the brink of analytical geometry, but then you start to get into calculus. And quite frankly, even though I got A's in mathematics, I actually have no aptitude for mathematics beyond the norm. I believe that's a fair statement. And so I was very fortunate, since I am a scientifically minded person, that I was able to get into programming, because programming has very little to do with mathematical ability. It was Stanford University that I would say pioneered the way in showing that mathematical aptitude is not the same as language aptitude. And in the study that I was interested in, there's one other category that's more spatial. But language and mathematics are two different aptitudes. And it turns out that programming is a language aptitude. And I'm extraordinarily gifted in language, although only relatively speaking. By any modern standard, I'm not excellent in anything. I'm a very ordinary person, I believe. But I did get interested in geometry. It was rekindled in my mind for reasons having to do with my personal life. I did need to begin to concentrate my attention on a subject. In other words, I needed to immerse myself in something. And just to give you the reason, it was because my wife died. And that was 14 years ago. I took up astronomy. And I am an astronomer. I'm not a professional astronomer, and I would like to do galactic astronomy, but you need to invest in quite a bit of equipment to do that. I haven't done that, but I do enjoy looking at the night sky. That will be a major theme throughout this discussion of a new geometry. This time last year, after having studied geometry of the heavens, really celestial mechanics, but intensifying after another event in my life, which was 4 years ago, which was the campfire which burned up my home and my life's work. And I did the same thing 4 years ago as I did 14 years ago, but it was redoubling my effort. I had already become immersed in geometric algebra, and I had studied spherical rotation for 10 years. So I am acquainted very deeply with what you might call spherical geometry, but there actually is no spherical geometry. But there is spherical trigonometry, because trigonometry, of course, is linear. And we use linear algebra and the linear number system to access curved space, and that's where science is at now. Now, my introduction to the deeper aspects of science began really closer to 4 years ago after the campfire, which destroyed my home not far from here in Chico and burned up every last bit of my possessions, including all the original manuscripts, of which there were no other copies except on the hard drives that I rather foolishly left because we all kind of thought we were going to return, but not very many people got to return to their homes. And mine was turned to ash, as was one of my best friend's homes right next to me. He had built his home up in Paradise. Really, one of the reasons I moved there was it was a golden opportunity. I was renting from his neighbor, but my best friend was living next to me. He has rebuilt his home. So both of our homes were turned to ash. And at that time, after nearly dying from smoke inhalation, I had asthma, although I am somewhat miraculously cured of that now. But I did have asthma, and I very nearly died from the smoke poisoning. And in fact, the man that I lived with in Chico for 1 year also almost died, and he wasn't even up in Paradise. He was breathing the smoke down in Chico. That's just a little thumbnail sketch, except that man was a mathematician, and since I had lost all my books, my entire library was burned up as well. He gave me a book, and it was the first book that I was given. I did buy one small book, which I still have, called Mathian Pathian, which is a beautiful little book. I thought it was poetry, but it's actually something quite a bit different. But the book that my landlord gave me, an old friend of the family, and I was very fortunate to get a room at all. It wasn't a very big room, but it was much better than being out on the street. But he gave me a book on quantum mechanics, of which I knew absolutely nothing. And it turned out, and this is still recognized to this day in many circles, it is the very best book on quantum mechanics ever written by the hand of man. And I've read it all the way through once, and I've gone back to it to read parts of it again. It's by a man named Kumar, Kumar. If you read that book on quantum mechanics, you will never need anything else to understand the genesis of the quantum mechanical revolution, which is now rather advanced. This quantum business, as Niels Bohr and a few other men have made some very interesting statements about quantum mechanics. Well, that was my introduction to the subject, and it was just somewhat miraculous. This is exactly, and I myself got another book right away by a man named Sir Roger Penrose, and you may have heard of this man. And I read his book all the way through on the laws of the universe, the very furthest extent of linear algebra, linear mathematics, our linear number system, our linear science. Everything in science is linear. And from studying the sphere so long and then taking up quantum mechanics, I became attracted to the Bloch sphere, which is a quantum mechanical sphere which defines what's now being used in quantum computing. And I became so fascinated with quantum computing that I began to study it, beginning with a man named Scott Aronson, if I'm remembering his name right, who is still the world's foremost authority on quantum computing. He might deny that, and I'm only speaking from my own point of view, always a dangerous thing to do, but my needs are very small in understanding anything in astronomy, astrophysics, mathematics, or programming or quantum computing. I want to know what it means. And I really am not interested in anything else. I'm not interested in philosophy or schools of thought or calculus. That's always a real bad deficit. To not understand calculus, you can't possibly understand cutting edge science without calculus. And the reason is that it's all linear. But we're now dealing with spheres. And in order for linear algebra to reach spheric anything, requires calculus. There's no way around it. And that's why we have billions of books on calculus that are thousands of pages thick. Impossible for a human in a whole lifetime to go through any one of these books and understand really much of any of it. And so it's only a very select few that ever get to the cutting edge of science now, due to calculus. Exclusively for that reason, there should be nothing difficult about science. There is when you get into engineering, which is the normal application on Earth. If you want to be a scientist, it's because you're going to make something. It's part of industry. You're part of the world. You're using science to make a living. You're using science. You can tell yourself that you're trying to better humanity, and a case can certainly be made for that, considering we now have refrigerators, every kind of engine. Our lives are better because of linear algebra, and there would be no modern age of technology were it not for calculus. We can do without the computers, but we cannot do without the calculus. And so calculus is now one of the defining terms for science, and that means that science has changed. Now, in my 250 videos, I'll just say it's 200, it's actually about 265, that are available now on YouTube. But one of the things that I talked about extensively as bracketing information for why this geometry that I discovered might be useful was to improve on linear algebra, to give us opportunities for insight and progress not currently available to science, which is quite a grandiose thing to claim, and I knew it. So a lot of those lectures talk about calculus, and it shows that I don't like it. And so I was quite aware of that, and I'd just like to sum up the whole thing right now to begin this series of a very formal, step-by-step presentation of what this geometry is. It's not calculus. And the way I began to explain this, and I'm going to say it again now, this geometry is not for technology. And the way science is now conceived in the minds of just an ordinary man or woman like you or me or anyone else, science is now identified with technology. And in most people's minds, I'm fairly sure this is a fair statement, just the general impression, what you would define to be science, just be honest. Well, of course it's technology. But is that all science is? Well, it's all science is now, yeah. But was anything left behind? Of course. We're a highly specialized society of scientists now. Almost, you could say, 99% of science is technology. Well, that's calculus. That's really, and why am I emphasizing that? It has to do with geometry. So, to start here with that bracketing information that I hope you find useful as I proceed now to tell you this geometry, it is the geometry of the sphere. And getting back to John Conway, his discovery, which triggered in my mind a sequence, I owe this, there's several names to whom I must give credit. And the first one, though, is Conway, because he gave me the definition of the linear number. And he was the first man in history to define completely and consistently what is a number. A number. A number. We're going to talk about the concept of the number and where the numbers are, which I discovered, although I really didn't. It's John Conway who discovered the definition of the line for the first time in history. Now, nobody's ever said that, and John himself did not claim that, but I claim it. Because by defining the number, he defined the line. The number line is a redundant term. When you say number, you're saying one of the numbers. And when you say the numbers, you're saying the line. And when you say the straight line, that's the only place that numbers are. Whenever you use a number, it's on a line, or it wouldn't be a number. And there are no numbers that are not on a line. And that's why we use 3 of them to make a coordinate system for empty space. We just say empty or vacuum space, or free space is a good term. But if you just say space, in geometry, space has more than one meaning. It's an abstract term that can be applied to a mathematical space. All of this is germane to our topic, and this is Geometry 101 in a way you've never heard it. So we're going to do this hierarchically. We're going to talk about what is a number, what is a geometric object, and in particular, what is a line? And then we're going to talk about reality. And we're going to put these together so you're going to have a very good map, not only for what I'm going to say, but for all of science. Because quite frankly, there's a lot of trouble in science right now. It doesn't show because the technology is dazzling. And if science were technology, then it's 100% success. And whatever it cost in calculus and human misery, having to learn calculus, and every sine, cosine, and everything that goes with it, including complex algebra, you have to master that now. You have to know all these things in your gut. You have to be able to think in terms of calculus, or you can't do science. Well, science is a pretty big term, isn't it? Science is that. What was science before technology? Was there such a thing? In other words, are we correct in teaching each other, as I was taught, and I think you were too, that Euclid was the first scientist? Now, of course, he was simply one of the first, but we know Euclid comparatively well compared with the others that came before him, who were also scientists as well, but not like Euclid. Euclid set the pace for 2,000 years. Not too many men have been able to do that in any subject, is to be the dominant. Well, of course, we were quite primitive back then, weren't we? By the standard of technology, yes. And it's been a long time since Euclid. But it is remarkable that the number system that was developed to support the geometry of Euclid over centuries, the numbers came second. First came geometry, and then came numbers. We associate them together, and it's really kind of tricky to say which came first, and a case could be made for either one. But now we know, thanks to John Horton Conway and in a small part myself simply to point this out, is now we know, absolutely know, why numbers and geometry are so closely related. It's because the number system that we use is the only number system that's ever been used, except you could say complex numbers. Those are not linear numbers, but actually they are. Because they're linearized by a special form of multiplication known as conjugate multiplication. But that's really the only exception. Einstein did not change that. And really, in fact, it turned out that complex numbers didn't change anything either, except for analysis. And analysis calculus is an analytical tool. It's not mathematics. It's analysis. Oh, it is mathematics, but it's an extension of linear mathematics. It's actually a new operator. And you could say two, but everyone knows from the fundamental law or principle of calculus, it's really just one thing. It's one operation that has, it's like plus and minus. That's one operation. And division, multiplication, that's one operator. We say there are four operators, but they're in pairs. And so the calculus has the integral and derivative calculus, but it's simply another operator. But it's not linear. It's a method of getting linearity out of curvature. And that's why we have calculus, is because we can't compute curvature. That's true. So we've used linear numbers exclusively throughout the history of science. And we've used exclusively linear geometry for that reason. Numbers are computable, so they've gained extra power in the advent of the computer age. Beginning shortly after World War II, electronic computers began to rise in science and in usefulness. And now everyone who's middle class or higher, in the West at least, and many people who really probably shouldn't have them, have handheld computers called cell phones. And both the iPhone series and the Android series are nothing short of supercomputers with quite a bit more functionality, such as instant contact with as many as 6 satellites or more to get GPS positioning. And also, they're being spied on by your own government, and that was uncovered by one of my heroes. I won't name him here, but he's in my videos. He's living in Moscow now, since if he comes back to the United States, the industry that I used to work for, which did include Verizon, for whom I worked for close to 8 years, they were the ones who were spying on the American public illegally. So that hero who uncovered that is now forced to live in Moscow, since if he comes back, the industry that I used to serve will murder him. And they've stated so publicly, and no president has even thought about pardoning this man. His name is Edward Snowden. He's one of my kind of men. One of the last of his kind. And he'll go down in history if there's any justice in history at all in the future. But Edward Snowden is living in Moscow against his will. He's an American who loves his country. And President Obama would not pardon him. And so I do not pardon Obama or any of the presidents since, including the present one. Joe Biden is a criminal. He has the option to pardon Edward Snowden and welcome him back, if not as a hero, at least as a full-class citizen, exempt from the illegal action taken against him by the industry I used to serve. So, there is a lot afoot these days with computers. But computers use linear logic. There can be no other geometry for the computers. They will use the numbers that they're using until hell freezes over. By the way, if you're interested in making millions of dollars and you're willing to sell your soul for it, you should go into quantum computing. I almost did. And if you do, you'll be a millionaire if you have the right stuff, but you will make an excellent living because the money pipeline is open from the government now for quantum computing. It will slowly rise. So far, it hasn't gotten off the ground, except they know they can do it. I actually got online. You can do this. And just type the right address. It's public domain. And there was a flurry of activity when this was first announced. You can actually, you have to believe what they're saying, but they were trying to publicize the fact that there are now quantum computers that can almost add. They don't get it right every time, but they will. In fact, by now, there probably are some that are consistent with simple addition, but you see they're not using linear logic. They're using quantum logic, which is Hadamard gate logic. I'm a master of that logic now, but only because I learned it from Scott Aronson. It's absolutely fascinating, but it's intrinsically related to spherical geometry. And that's when I started thinking and researching much more intensely than I ever had before. And I started studying the number line. And I started studying numbers. And I was also into geometric algebra, which I was studying before the campfire. And I'm somewhat of a pro at that too. But not in the industrial sense, only in the sense that I understand them. And what did this do for me? It led to a discovery, and it was in January 1 year ago, this time of year, that I started realizing that I was probably, I'm not sure I can explain this very well, and it may not sound like I am remembering very well, but I knew that I was going to make a discovery. I could feel it. And sure enough, by June, and having already made about 100 videos just so I could talk to myself. I live alone. I have lived alone for 14 years since my beloved wife died. She was from Kiev, Ukraine, and I lived there in Kiev, Ukraine to court her hand. And I also lived there illegally for a while. But she did agree to marry me, and we got married, but then she died of cancer. I've lived alone ever since, although a cat has adopted me, which I'm very happy about. But this gives me plenty of time. I haven't worked in 14 years. As soon as Verizon decided that they weren't going to give me one more leave to go visit my wife's grave, I quit. And that was before I knew about what Edward Snowden had discovered. So I quit them in good faith, not in vengeance like I hated them, but I thought that they were acting quite unrighteously by not granting me one more leave. And the reason that HR gave me is because their workforce is populated by spoiled brats. They were on the average about half my age, and I was considered to be extremely good. Verizon did not want to lose me, but they would not back down because the spoiled goddamn brats that worked there would have raised a stink and demanded more leave themselves. This was the fear. I don't know how they could justify this fear. It is a once in a company case where a man asks to fly to Kiev to see his wife's grave. I intended to come back and work for them. It's probably a good thing I didn't, because once I found out what Edward Snowden uncovered about what those bastards were doing, spying on us, through our cell phones, I don't know what I might have thought or done. Oh, I certainly would have quit. But I haven't worked since. I haven't worked in 14 years. I was fortunate to get Social Security based on being a widower. When you get it earlier than age 65, you can get it at age... Actually, I'm not even sure how that works, but I got it at age 61 or 2. Which saved my skin since I let my money run out and I was going to just die. If you don't have money in this world, you die. And that's what I was going to do. But I didn't want to commit suicide, so I just let my money run out. So that's a little more history, maybe more than you wanted to know, but that does explain why I've been able to concentrate on an extremely important subject, which nobody else is studying at all. The geometry of the sphere. And from intensifying my efforts and getting feedback by using videos that I was making at home, no intention of ever uploading to YouTube. But I needed feedback and I learned a lot from listening to myself, particularly how to express myself. And I've polished my act quite a bit over this past year. But in June I was ready because I had made the discovery. I was certain that I had discovered the geometry of the sphere. And so you know how I knew that. This will answer quite a few questions of what this geometry even could be, if there even could be such a thing. Because don't forget, no man in history has ever thought of this. I am certain that other men thought of this, but they encountered the same problems that I encountered. And I now liken that to a fish ladder, whereas a salmon, you can't swim up the waterfall. But as a ladder is built, humans do this for the salmon, where the salmon can jump into a pond and then jump to the next pond, and after a discrete number of jumps, it can get up to the higher level of water and continue to swim upstream. And the salmon are smart enough to know this, and they will jump. Think of each one of those jumps as being a jump that you can't cut corners. You can't like jump to the second and fourth and sixth. You have to take them one at a time, and each one is a paradox. And this is a series of paradoxes against the whole idea of there being any other geometry except linear geometry, which again is science. That's all science is. To this day is the geometry of the line. No other object is used or ever has been or ever will be, unless I'm right. But one of the first, I won't mention these paradoxes in any particular order, although in the past 3 lectures I've named about a half a dozen of these paradoxes that must be faced one by one. But just the first one is enough to turn most people off to the whole idea, I believe, which is you're going to need a number system for whatever geometry you invent. Well, the first thing one has to think about is there some other object besides the straight line which might be useful to science? And the answer is obvious. The sphere. The sphere. The sphere has been discovered by modern physics to be everything. Everything is spherical. Gravity is spherical. Particles are spherical. Astronomical macroscale objects beginning at the star are spherical. Even planets are spherical. Nobody has ever thought about that. The universe is now known to be spherical. Or you could say that, if you're willing to go out on a limb, which I certainly am now, everything is spherical. Everything is spherical. and you see spherically. That was discovered in my lifetime. Although we always knew it, in science you do have to prove what you say, and that was quite difficult. And the neurophysiologists actually argued about this, because what's the alternative? Flat screen. In other words, the way we see and it goes into our mind, and somehow we reconstruct space. Well, is it flat or is it something else? It's both. We do both. And we can see in a straight line. So we do see linearly. But we also see spherically, because when you're focusing on something, you can still see peripherally everything around it. That's spherical vision. But it is difficult to say whether we linearize it in our minds to a flat screen, because we can't tell the difference. There is no difference between a flat screen image, such as a movie, or you looking at me on this screen. You can't tell the difference. Whether I'm there in the room with you, spatially, or if it's just an illusion. The flat screen is an illusion. Oh, it's a very convincing illusion. This is one of the hurdles in discussing a spherical geometry, is that nobody was sure there was such a thing, because there's definitely linear geometry. There's definitely linear vision. And it would be more or less philosophical to even talk about a spherical geometry. But why? Why couldn't there be a spherical geometry? There's a linear geometry, and the line is a geometric object. So why not for the sphere? Because it wouldn't have linear numbers, is the first paradox. And if you don't have linear numbers, your computers can't use. And why would you need numbers? Because if you don't have numbers for the spherical space, you have to go back to linear numbers, which means you need calculus. Now, why do you need calculus? I keep saying that. You might not be sure of why I keep saying that. It's because if you draw a curve, for instance, a circle is simply a uniform curve. Well, that's not straight, is it? Well, how do you compute the distance around the circle? The answer is you cannot. It's irrational. And that term irrational is critical. We'll come back to that. But you see the hierarchy. We have the line not because the line is wonderful. It's because it has numbers on it. In other words, we see the line. We do. We use it to compute distance. Do we not? Do you compute a curved distance to the sun or moon? No. You get a straight line. Well, that's what distance is. It's a straight line distance. There's no other kind of distance that's ever been talked about. It's always a straight line. It's a given. We need to start questioning that a little bit. Yes, I would admit that it's a given, but are you saying enough? So we begin, as I began last year, in examining the number system of the line. Conway gave me the key. The line is the number system, and you can accept that. That has been proved. So that line is science. It's the only geometry that science has. It's the only vision that humans have, and it's the only form of computation known. Is 0-1 binary logic for circuit logic. You need the 0 and the 1. That's linear. The 0 and the 1 are those two numbers. And that's why we can program our computers so efficiently. It's because of linear numbers. So to talk about spherical numbers, you're actually in the fear would be is that you're talking about something that cannot be computed. Well, maybe you don't want computation. I decided that I wanted to make sure, one way or the other, if the sphere might have a computational number system. And you might think this is the paradox. That's impossible. I just said so. The straight line is the numbers. So if you're talking about a circle or a sphere, both of which are curved surfaces, the circle is special, but the sphere is well known in physics. In fact, the circle is too, because of the elliptical orbit of planets around the sun. That's a circle. The ellipse is a circle. You may have heard that stated the other way. That would be more accurate, but I'm saying it this way to get you to start to think. The ellipse is exactly the same thing as a circle. It's not a line, is it? Yes and no. Yes and no. Because we are trying to compute distance on the circle. And we compute that in something called radians. Do you know why we use radians? Because the unit is 1. You can make the radius of a circle be linear 1. And now you have a geometric linear 1 embedded in the circle. I noticed that. And now you can use that unit to compute distance on the circle. But there's a big, big owie when you do that. The number that you get, no matter what you do, will not be rational. It will always be irrational. And that means that somebody had to figure out how to compute circular and spherical and curvature space. Curves. We say 2D for a parabola, hyperbola, ellipse, and circle. Those are 2D things. But they all can be extended to what we call 3D. What really should be called real space, proportion, which we linearize, and that's why we say 3D. The flat ones, like the circle, and even the square and triangle are all flat. Well, that's 2D. 2 lines, vertical and horizontal. But if you draw the third one, you can use that cubic space to compute volume. And that's how we attacked the sphere. The sphere is notorious for confusing the shit out of even geniuses. And Albert Einstein, when he went from special relativity to general relativity, do you know what the difference between those two is? It's quite difficult to state what the difference is between special and general relativity, but I can tell you what the difference is. Special relativity does not need to think about spheres, but general relativity does. And so general relativity is the very first formulation of pseudo-spheric geometry. I say pseudo because it's not spheric. It's 4D. 4 lines, one of which is imaginary. And in order to make this work, for general relativity to work, I've explained this before, but I'm just summing it up. Of the 4 lines, one of them is imaginary. And that means that it's negative. And that means the space is inside out. It's hyperbolic. And it's also negative. So the signature for this space is the most difficult to visualize and most difficult to compute thing that's ever been attacked by the mind of man. And only Albert Einstein got it. And he got it right. He got the linear solution for gravity space. And he gave it a name. Space-time. He didn't invent space-time. Minkowski did. Hermann Minkowski invented it. He invented the geometry for it, too. And Albert ran with it. And Minkowski never held a grudge. They were fine about that. It was never a contest, apparently. But rarely do you hear that stated, that it was Minkowski who had the idea. But it was Albert who worked out the curvature equations. Because special relativity, that was good practice for Albert to attack the problem of simultaneity. He was trying to get at time. So was Henri Poincaré, right across the border from Albert. Albert was in Switzerland, Schweiz, and Henri was in France, if I'm saying that right, France. And they were working on train schedules. Both of them were train schedules. That's why you have so many Gedankenexperimenten with trains. He was working not on gravity. He was working on simultaneity, which introduces a new data type into science called event space. And this was only poorly recognized at the time. It took until 2022 to start to realize how all of this connects with the line and the sphere. We'll be talking about the circle. That is a very important intermediary object because it's a linearized sphere. But the sphere is the only object that the universe understands. It does, however, also understand the straight line. And it's a very good thing that the universe does understand linear algebra. It does. We were blueprinted with the linear number system in our minds already, so that when we saw the line and started to figure out the number system of the line, our minds were all ready for that. Well, what I discovered is, from all the sources I've just named so far, our mind is also all ready for the sphere. And therefore I decided that the sphere has to have a number system of its own. And the first paradox was, will it be computable numbers? Yes. I proved that. These are fully computable linear numbers. But there has to be some way to make them completely different so they don't describe the line at all. In other words, we want to use the linear numbers, but get them off of the line completely and throw the line away forever. You can't. And that was one of the paradoxes that I had to face. I realized that in order for this to work, that is, for the sphere to have its own number system, they had to be linear numbers. And that sounds like a contradiction, because it's been proved that linear numbers only have meaning on a line. They have no other meaning except spatial, linear separation. That's all 1, 2, 3, 4, -1, negative anything, decimals, fractions, rational or irrational. They're all spatial separation. That's it. Well, we need more now. And Albert broke the mold. He did not see what I have seen. That was impossible for Albert. He didn't know what I know. One could always say, well, he might have jumped the ladder like you did. Just face each paradox. He's not a geometer. He's a mathematician. He was working out calculus, and he invented four-tensor calculus with a notorious, it's called the gamma term. And you haven't lived until you've studied Einstein's field equation to see if you can figure out what it's actually doing. That's very difficult to do, but I forced myself to do it. And I recommend you will have to have a good teacher or you'll never figure it out. Nobody can explain Albert Einstein's field equation to someone like you or me. It's impossible unless the teacher is extremely gifted. And there is one. I don't know the man's name, but I'll tell you his YouTube site. It's called Dr. Physics A. Dr. Physics, one word, and A tacked on at the end. Dr. Physics A. Dr. Physics A. It's a 6-hour lecture series on the Einstein field equation. I watched it twice. The first time I got it, but I know me, and I waited a while, and then I watched it again. It's a damn good thing I watched it the second time, and then I got it. I know what Albert Einstein did. It's horrendous. It's absolutely sinful what he was for. Not that he sinned, just that somebody had to do this. Is the only way we would ever advance into the modern age. It was the only way we would ever get nuclear weapons, the only way we would have a modern, comfortable way of life with a death threat hanging over our heads at all time. It's all because of Albert Einstein. Because he took linear algebra beyond anything that anybody thought was even possible. He linearized spherical space with time in it. And it works. And that's where we're going to begin. But that's 1 hour. We'll continue this tomorrow. That'll be a Sunday, the 15th of January. And I will present to you the series of paradoxes that had to be conquered to prove that spherical geometry exists with its own number system that is computable. I will be teaching that to you from now until the summer solstice. And if I'm right, as I know that I am right, but science does not accept anybody's word for anything. And I have entrusted my soul to that vow. I follow science, even if the modern physicists do not. And they don't. But I do. So I'll be talking a little bit more about what is real science, just to sum up what I know about science. And I assure you that even though what I say has not strictly been proved yet, I will prove it to you. To science. You are now science. If you're listening to me, you're science receiving new instructions. And if I'm wrong, oh well, I'm not. So we'll be back tomorrow with another 1 hour lecture. That's 1 hour. I do like to keep these videos to 40 minutes. That's not going to be possible for these lectures. Once I get started, this is going to be dense, and it's going to be the best science you've ever heard. And I'll prove that too. So stay tuned. I don't ask for money. Don't send me any. My payment is to get this out. But I don't even want my name attached to it. This will never be attributed to me. I want you to steal this. And you'll be better than a millionaire if you do. You can't take money with you. You can take this with you if it sticks. That will be up to you, though. and I'll be explaining that in extraordinary detail. And it's going to get extremely philosophical, beyond anything that you've heard in the papers about quantum or relativistic anything. I'm going to explain the universe to you, and nobody else can do that now. And if you wish, and I strongly recommend that you at least take a look, go to my site called anagalactic.space and click on a few of the playlist links. These links that I have at that page, anagalactic.space. That's all you need to type into your browser. Anagalactic.space. I'll keep that updated. This is the most important breakthrough in the history of science. It's the geometry that explains physics and does a shitload more than that. And that's where we have to leave off. Tune in tomorrow, where I'm going to continue the stepladder of paradoxes that everyone has not been able to jump the stepladder to get to the next level. And just to close off, to give you just a little bit of what we're going to cover as we proceed through the weeks until summer, this is actual evolution. Evolution has nothing to do with biology. The species cannot change, that's been proved. The code is locked. And there's no such thing as natural selection, Darwinism, or biological evolution. All the animals that are on the planet now have been that way since the beginning, whatever you think that is. I will not be covering that. But that is in some of my previous lectures. We're not going into religion. We're going to go beyond it. And we're not going to be talking about the problems in science or the exciting things in science. We're going to go right past it. We're going to get the answers that science has always wanted, what humanity has always wanted. But it's not going to be technology. It's not going to be calculus. It's not going to give you a better life with money. It's going to give you something far more precious that all the philosophers that were ever onto anything good, and there were some in Egypt, India, Greece, and a few other places, these men just crop up like... and it's beyond religion. It's what religion is actually based on. Whatever religion, especially the one that you hate. And every person who's into religion hates something. That's the deadly aspect of religion. This is the pure truth. That's what you want. Science cannot give that to you. Neither can philosophy and neither can religion. Only you can ever know what the truth is. You have to find it. I'm going to show you how you can go about that. It's not the only way. It's the best way if you're a scientist. You'll be using your rational mind with geometry, not numbers. Not numbers. That's what we'll be talking about tomorrow. Stay tuned, Anagalactic.